Here we go. Let's work on this calculator interactive question. Unit 6 progress check. Free response questions, part B, number 1. It's the only one in part B. And we shall begin. They gave us a function, and the function was this. And they're going to do all kinds of fun stuff with this one single function. Part A says, approximate the value of the integral from 1 to 12 of f of x, finding the area under a curve, approximating the area under a curve, using a left Riemann sum with subintervals from 1 to 4, 4 to 8, and 8 to 12. Whoa, what? Okay. We are going to set up a left Riemann sum with 3 subintervals, 3 rectangles, if you want to call it like that. You do not have to draw this. You get no points for drawing this. Don't draw this, actually, on your AP test, but just for a visual, this is what's happening. 4 over x squared is one of these kind of deals right here. And we're going to approximate what happens from 1 to 12 by going from, well, 1 to 4, 4 to 8, and 8 to 12. There we go. And we'll be using a left Riemann sum. Again, you don't have to draw this. This might be a waste of your time, but this, here it goes. There's your first one. Clearly, we're going to have an overestimate, just saying. We're going to have this one. If you didn't know the shape of this, actually, it does not impact the way that you do this, but still. There, that one was blue, and that one's purple, that one's blue, but you can barely tell. But the point is, when we set this up, we're going to have, well, 3 rectangles, sorry. And the first one is going to have a width of 3 and a height of, well, f of 1. And all this that I'm writing here just kind of comes from this visual. I would have just jumped straight here, but I wanted to give you the visual for it. Again, no points for drawing this. 4 f of 4, 4 because 4 to 8, and then 4 again, plus 4 f of 8, and we'll figure this out by hand, and it is totally doable. So 3 times f of 1, plug a 1 in, you'd get a 4. All right, plus 4. All right, plug a 4 in here. If you plug a 4 in here, you'd have 4 over 4 squared. That would just give me 1/4. That's convenient. And then 4, and then we're going to plug in an 8. We have 4 over 8 squared. 8 squared is 64. 4 divided by 64 is going to give me 1/16. And now we'll just do some simple math. Okay, so 12 plus 1, so 13 so far. And 4 times 1/16 is 1/4. Actually, in a free response question at this point, you could leave it like that. You would get credit. I'm going to keep going just because I'm having so much fun I can't stop. And I end up with 53 over 4. Let me tell you where you can stop. Again, you can stop here. Don't stop here. Don't stop there, because we need to know, they need to know, they being the people that grade your paper, need to know that you know what f of 1 is, what f of 4 is, what f of 8 is, that sort of thing. All right, part B. Find the value from 1 to 12 of f of x dx, and then show the work that leads to your answer, and we will do this again without a calculator. Totally doable, actually very reasonable. The integral from 1 to 12 of our actual function, which is 4 over x squared dx, and just doing something that can potentially happen in your head at this point, but I'm doing it anyway because I get paid to explain things. There we go. Add 1 to your exponent. 4 divided by -1 is -4. We're going to do this from 1 to 12. Once you've taken the antiderivative, you do not need the integral symbol. Please don't put that back in there. That's going to give me, 12. -4, 12 to the -1, minus -4, 1 to the -1. That means I have -4 over 12 plus 4 over 1. We'll just go ahead and call it what it is. So -1/3 plus 4, and that is going to give me 3 2/3, and that would be 11/3. And again, when they grade these now, they don't, they're totally fine if you stop somewhere along in here. Where? Okay, well, don't stop here, don't stop here, don't stop here, don't stop here. I think you can stop here, but I would feel more comfortable for your sake if you stopped here. I think that would be reasonable. Okay, that negative exponent, I mean, you probably could get away with that, but that's too much of a risk for my taste. All right, part C. Find the value from 1 to infinity of f of x dx. or explain why it doesn't exist. Okay, well, you can't plug in an infinity, but you can approach an infinity. So let's rewrite this again. We're going to have an improper integral. Improper integrals are integrals that go to infinity or negative infinity, or or have the potential to cross over a boundary that has a discontinuity. That does not happen in this case. So we are going from 1 to infinity. Nah, we can't go there. We'll go to b instead, but we can let b approach infinity, and we'll compute it that way, of our function, which is 4 over x squared dx, and now we are ready to proceed. So we can go ahead and take the antiderivative, just as we did up here. We're going to get the same thing. So we have the limit, as b approaches infinity, of negative 4x to the negative 1 from 1 to b. So it looks exactly the same as this, only we are going to infinity. So let's proceed. Just for the sake of visualizing what's about to happen with the infinity, I'm going to rearrange things just a little bit. So we're going to have negative 4 over x, let's go ahead and call it x, and minus, oops, sorry, I was plugging things in while trying not to plug things in. There we go. This is what I really have. We're going to go from 1 to b. So we'll have the limit as b approaches infinity of negative 4 over b minus negative 4 over 1. Okay, now let's not plug in infinity, but at least think about what would happen if we did. As we approach infinity, negative 4 over big, biggity, big. Well, when you have a huge denominator that completely overpowers your numerator, this really approaches 0. So we really have 0 plus 4, which is just, well, 4. No surprises there. Okay, now we get to some very interesting stuff, and this one's going to take a little bit more time. Part D asks us to do a very different kind of integral, and it's going to involve integration by parts. There's a dot on my paper right there. It's going to drive me crazy if I don't turn this paper over. Oh, good. There's not one on the other side, and it didn't bleed through. Okay, here goes. Part D. Part D asks us to find the value from 1 to 12 of f of x times the natural log of x dx. Okay, here's what I noticed, just without even going any further. We are taking the integral of a couple things that are multiplied together. And because they are multiplied together, we really kind of have I don't want to call it a product rule, but we are going to treat it using integration by parts, which is an extension of the product rule. So let's write it down. Here's what's happening. It's happening in red. The integral of u dv is equal to uv minus the integral of v du. That's what's really happening, okay? And again, this comes from the product rule. It's just a handy little thing to have. So we need to identify our parts. Before we go any further, let's just go ahead and really write it the way it is. We know what f of x is. It's 4 over x squared times natural log of x and then dx. Okay, I'm going to grab a scrap piece of paper and tell you what not to do. Here's what not to do. And if you don't know not to do this, it's okay. You can lose a little time in this process, but you kind of experiment with it. You have to pick a u and a dv. So in a minute, I'm going to be like, u is this and dv is that. And those are the two things that I have to pick. Like that's where I start this process. And some bleed through on the back of that. Sorry, it's a scrap piece of paper, as I said. And then we'll have du, and we'll also have v. So we'll derivatize u to get that. That's not a word. We'll integrate this to get that. What not to do is this. Don't be like, oh, well, we'll let natural log of x dx be dv. And then you'll have to integrate natural log of x dx. That is actually something you're not expected to know what it is. And so as you go from here to here, actually the integral of natural log of x dx requires this whole process anyway. I never, ever, ever have done one of these where I let the dv be a logarithm. The logarithm should be over here. All right, all that said, let's do it correctly. The whole thing would have fallen apart, because then you'd be like, well, what's the integral of a natural log? And I don't remember learning that. Well, you didn't learn that. I mean, you've seen it, but it's not an expectation that you know it. Okay, it's not one of the formulas you have to memorize. U equals something and dv equals something. And again, this is important because these are the two things that we pick and everything else is built around them. So I'm going to need du, that's something, v is something. And as was just established, natural log should not be this one. Natural log should be this one, natural log of x. And the derivative of natural log of x is 1 over x. There's no surprises there. 1 over x dx. We'll put that in there. Kind of important for notational purposes and operational purposes. Everything else will go here, 4 over x squared dx. And we'll integrate 4 over x squared. We actually have already done that twice in the process of doing this problem, so it's negative 4 over x. We'll handle our c's later. We are ready to take this idea, plug it into this formula, so let's do it. So we have integral of u dv, that is this, or this, depending on how you look at it. And we are going to plug in u, v, and integral of v du, simplify some stuff, and we will not be done yet, because this is a definite integral, okay? So I'm going to switch back to this color right here. And we are going to continue to fill in this. This is going to correspond to that formula. So uv. So natural log of x times negative 4 over x. Usually those are written in a different order. And then on the next step, I might put that one in the front. But the thing is this. We have already integrated it somewhat, at least this term is. So we're going to take this term from 1 to 12. And then we'll continue with this one, which is not yet integrated, from 1 to 12 of v du, so v du. So we're going to have negative 4 over x times 1 over x. It's getting ahead of myself in my brain and then messed me up there. Okay, so we still have some work to do over here. So all this that I wrote in blue is just a good little setup, but it's going to get in my way, so my work's going to continue down here. Part of this is keeping your work organized. So let's plug in a 12, let's plug in a 1. I'm going to rearrange this. I just don't like the negative 4 over x's at the end. So negative 4 over 12 times the natural log of 12. That's my first term. And then minus negative 4 over 1 times the natural log of 1. And so that takes care of this. This is fundamental theorem of calculus where you're plugging this in and subtracting. And then minus, well, actually, no, let's not minus. Let's call it plus, because that's what it really is. Shall we? Yeah, let's do it. Okay, negative is going to make this plus, and I'm going to simplify a little bit here. So we have 1 to 12 of 4 over x squared dx, which is pretty much what we've integrated like a million times already, 3 times already. So let's continue to simplify. Well, first of all, that's negative 1/3 natural log of 12. Don't be like, oh, it's calculator inactive. What's the natural log of 12? They don't expect you to know that. Don't play that game. It's the natural log of 12. 4 times the natural log of 1. Natural log of 1 is 0. So this entire term, he's gone. Lucky us. That simplifies my life quite a bit. But we can take the integral of 4 over x squared, which is, well, you've been through this, negative 4 over x. You kind of know that. There it is. There it was. It was also in part C. It was also in part B. I mean, you've done this, right? You miss this when you miss everything. So we have that, and it's going to go from 1 to 12. All right, so we can get a little messed up with this subtraction sign. It's a little bit, it can be a little bit confusing, so I'm going to put the parentheses here. If you put plus a negative and put the negative in there, it'll still work out. So we have negative 1/3 natural log of 12 minus 4 over 12 minus, there we go, mess this up if we're not careful. Actually, I think I just accidentally misspoke. If we put the negative sign on the inside and put a plus there, it still works. Yes, it still works. Okay, all right, good. We're good to go. I messed up right there. I messed up in explaining how I had messed up when I didn't mess up when I thought I'd messed up. Let's move on. We're going to subtract 4 over 1, and then we just have a little bit of extra math to do. It's not going to be hard at all. So we have negative 1/3 natural log of 12 minus, and we'll do a whole lot in our head right here. We have 1/3 minus 4. 1/3 minus 4 is a negative number. It's negative 11 thirds. Let's go one more step. It's just for fun. 1/3 natural log of 12 plus 11 thirds. Again, they are not expecting you to simplify all the way down to here. I think we could probably, you got to go beyond here. You got to plug that stuff in. I believe it's totally reasonable to stop right there.